Now, in this lecture, we'll find out the radius of the semicircle. In the drawing, we have a semicircle. Line segment PA is tangent to the semicircle at point A. And we also know that the length of line segment PA is equal to 6 units. Line segment PQ equals to 4 units in its length. Line segment PS cuts the semicircle at points Q and S. In addition, we know that QS equals to QC. This is angle PAB that is equal to 90 degrees in size. And this is angle SQC that is also equal to 90 degrees. Our mission is to find out the radius of this semicircle. So first of all, I present to you a new wall, and we will implement a new wall in our drawing. The new wall is wall number 10, and according to wall number 10, if we have a common external point P, from the common external point P, if we draw tangent PT, and also from the same common external point P, we draw line segment PB that cuts the circle at points A and B. So in this drawing, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement wall number 10 in our drawing. While in our drawing, we focus on the common external point P. From the common external point P, we have tangent PA that is tangent to the semicircle at point A, and from the same common external point P, we have line segment PS that cuts the semicircle at points Q and S. So all the requirements of wall number 10 are satisfied, therefore we can implement here wall number 10. According to wall number 10, PA square equals to PQ times PS. I repeat again, according to wall number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ. PQ is 4 times PS. In total, PS equals to PQ plus QS. That is to say, read again, 36 equals to 4 times PS, and PS is PQ plus QS. PQ is 4, so in total PS equals to 4 plus QS. So 4 equals to 36 equals to 4 times 4 plus QS. Here we divide this equation by 4, and we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we will divide this equation by, we will subtract from this equation 4, and finally we'll get that QS equals to 9 minus 4, that is 5. So chord QS equals to 5 units in its length, and because of the fact that it is given us the question that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, I will present to you rule number 3 and implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. So if we focus on the upper side on the straight line AB, it's point Q. Here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and the other angle beta. So in total, the sum of those two angles must be equal to 180 degrees. That is to say, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. You can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees. Repeat again. In order to complete the sum of the angles in the lower side of the straight line PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we'll join points P and C together by a straight line. By joining points P and C, we created the right triangle, triangle PQC. So I'll copy the right triangle, PQC in a new page, and we will implement on this right triangle PQC the Pythagoras theorem. Here by PT is a relation for Pythagoras theorem. Side PQ equals to 4 units in its length, according to what is given us the question. And just right now found out that QC equals to 5 units. So actually, this is the right triangle PQC that I copied from the original drawing. Here by PT is a relation for Pythagoras theorem. So in this right triangle, triangle PQC, according to the Pythagoras theorem, PC square PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total PC square equals to 16 plus 25, that is 41. In conclusion, found out that PC square equals to 41. In the next step, I'll copy the right triangle PAC in a new page and we'll implement the Pythagoras theorem in this right triangle PAC. Again, by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given as the question. And we already found out that PC squared, that is the square of the hypotenuse, equals to 41. So in this right triangle PAC, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, we get that PC square equals to PA square plus AC square. PC square is 41 and it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. So I found out that 41 equals to 36 plus AC square. We subtract 36 from this equation. And finally, we get that AC square equals to 41 minus 6 is 5. So AC square equals to 5. We take a root out of this equation. And finally, we get that AC equals to the square root of 5 units. Slide AC equals to the square root of 5 units. So the right here, the original drawing, that AC equals to the square root of 5 units. It's there. We know that this is a semicircle, and therefore AB must be the diameter of the semicircle. So I'll write it down. AB is the diameter of the semicircle. If we define the radius of this semicircle as x, the radius of this semicircle is the radius that we are looking for. So if the radius of this semicircle is x, then the diameter AB must be equal to 2x. So, what is the length of line segment CB? For the drawing, it is very easy to see that CB equals to AB minus AC. Again, CB equals to AB minus AC. So I write it down. CB equals to AB minus AC. So CB equals to AB. AB is the diameter of the semicircle that is equal to 2x minus AC. AC is equal to 5 units. So CB in total equals to 2x minus equal to 5 units. So I can write here that CB equals to 2x minus equal to 5 units. In the next step, we will complete the semicircle to a circle. Completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as M. In the next step, I will present to you rule number 11, and we will implement rule number 11 in our drawing. According to rule number 11, in the drawing we have a circle. Inside the circle, chord AB intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. And whenever you have two chords inside the circle that intersects with each other, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. You can actually implement rule number 11 in our drawing. Why? Because in our drawing we also have two chords that intersect with each other. Here, chord AB intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. For that reason, we can implement rule number 11. So, I write it down. Chord AB intersects with chord QM point C. Whenever you have two chords that intersect with each other, you can implement rule number 11. So according to rule number 11, the following equation will be true. AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again. According to rule number 11, in our original drawing, AC times CB equals to QC times CM. AC is equal to 5 times CM. CM is 2x minus square root of 5. And it is equals to QC. QC is 5 times CM. We will define the length of side CM as B. If we will find out that according to rule number 11, square root of 5 times 2x minus square root of 5 equals to 5b. So here we will divide this equation number 1 by square root of 5. And we get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation number 1 square root of 5. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. Repeat again. According to equation 1, found out that 2x equals to 5b over square root of 5 plus square root of 5. So here we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5 in order to overcome factor with this expression. And we get that according to equation number 1, x equals to 5b over square root of 5 plus we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5, so we actually change nothing, therefore this operation is allowable. In conclusion, found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. So here we divide this equation number 1 by 2, and we get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Repeat again. According to equation number 1, we found out that x equals to 5b plus 5 or 2 times root of 5. In the next step, we will join points S and M together by a straight line, those 2 points. By joining points S and M, we actually created a peripheral angle SQM. This peripheral angle SQM equals to 90 degrees in its size. So I write it down. Peripheral angle SQM equals to 90 degrees in its size. Peripheral angle SQM equals to 90 degrees in its size. And we have 1/5 that relates to any peripheral angle that is equal to 90 degrees. According to 1/5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside this circle we have peripheral angle MAN. This is peripheral angle MAN that is equal to 90 degrees in its size. Point O is the center of the circle. So according to rule number 5, because of the fact that peripheral angle MAN equals to 90 degrees in its size, therefore peripheral angle MAN must rest on the diameter of the circle. From the domain itself, it is very easy to see that peripheral angle MAN rests on chord MN, and therefore chord MN must be the diameter of the circle. And indeed, chord MN is the diameter of the circle. Why? Because it passes for point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MAN equals to 90 degrees, therefore it must rest on MN on the diameter of the circle, and indeed MN is the diameter of the circle. You can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle SQM. This is peripheral angle SQM that is equal to 90 degrees in its size. Therefore, according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on chord SM, and therefore, according to rule number 5, chord SM must be the diameter of the circle. So, I repeat again, because of the fact that peripheral angle SQM equals to 90 degrees in size, therefore, according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on chord SM, therefore chord SM must be the diameter of the circle. So, according to rule number 5, chord SM is the diameter of the circle. According to our definition, the radius of the circle is x, therefore the diameter SM must be equal to 2x. So SM equals to 2x. In the next step, I will copy the right triangle, triangle SQM in a new page, and we will implement on this right triangle, triangle SQM, the Pythagoras theorem. Side QS equals to 5 units in its length. What is the length of side QM? Well, we know it is very easy to say that QM equals to QC plus CM. That is to say, QM equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. Okay, again, we will decide QM equals to 5 plus B. And QC equals to 5 units, QS equals to 5 units instead. We have only found out that the hypotenuse SM according to rule number 5 equals to 2x. The hypotenuse is also the diameter of the circle. So SM equals to 2x. According to the Pythagoras theorem, in the right triangle, triangle QSM, by PT is a relation for Pythagoras theorem. So in the right triangle, triangle QSM, SM squared equals to QS squared plus QM squared. SM, the hypotenuse SM equals to 2x, therefore SM squared is 2x squared, and it is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. In conclusion, we found out that according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2. While according to equation number 1, we have only found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute x in this equation, equation number 2, by the value that we found for x in this equation, equation number 1. So according to equation number 2, 2x squared, in this other equation number 2 we have 2x squared, so it is 2 times x according to equation number 1 is 5b plus 5 over 2 times square root of 5 squared. 2x squared. So this expression equals to x, so it is 2x squared. That is equals to 25 plus 5 plus b squared. Repeat again, we substitute x in this equation, equation number 2, but the value that we found for x in this equation, equation number 1. So in this side of equation number 2 we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, this is the equation number 2. After we cancel 2, we left only in the numerator with 5b plus 5 square over square root of 5 square. Square root of 5 square is 5. So in total, this expression equals to 5b plus 5 square over 5, and it is equals to 25 plus 5 plus b square equals to 5 square, that is 25, plus b square plus 2 times 5b, that is 10b. So, according to equation number 2, we actually found out that 5b plus 5 square over 5 equals to 25 plus 25 plus b square plus 10b. We'll open the brackets on this side of equation number 2. And we get that according to this equation, equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b, all divided by 5. And it is equals to 25 plus 25 is 50, plus b squared plus 10b. So in this side of equation number 2 we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b, and it is equals to 50 plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After cancel 10b, in this side of equation number 2 we left only with 5b squared plus 5, that is equals on the other side of equation number 2. After cancel 10b, we left only with 50 plus b squared. Here we subtract b squared from this equation, equation number 2, and we get that according to equation number 2, 5b squared minus b squared is 4b squared, plus 5, that is equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45, so 4b squared equals to 45. Here we divide this equation, equation number 2 by 4, and we get that according to equation number 2, b squared equals to 45 over 4. So according to equation number 2, b squared equals to 45 over 4. B squared equals to 45. We substitute 45 by 9 times 5 over 4. Here we take a root out of this equation, equation number 2, and finally we get that b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3 over 4. The square root of 4 is 2. So inside the root we'll have to only be 5. In conclusion, found out that b equals to 3 times root of 5 over 2. This is according to equation number 2. While according to equation number 1, we've already found out that x equals to 5b plus 5 over 2 times root of 5. So we have the value of b in terms of numbers. Therefore, we can substitute b in this equation number 2 by we can put the value of b from equation number 2 inside b in this equation number 1. And we get that according to equation number 1, x equals to 5b, and b according to equation number 2 is 3 times square root of 5 over 2, so it will be 5 times b according to equation number 2, b is 3 times root of 5 over 2 plus 5 over 2 times root of 5. So we found out that according to equation number 1, x equals to 5 times 3 is 15, so in total this expression equals to 15 times root of 5 over 2 plus 5 over 2 times root of 5. So here we will multiply 5 by 2 and then we will divide it by 2 in order to have a common factor with this expression. And we get that according to equation number 1, x equals to 15 times root of 5 over 2. Again, here we will multiply 5 by 2. 5 times 2 is 10, and then we will divide it by 2, so we change nothing. All divided by 2 times root of 5. So here we'll move 2 times root of 5 to the denominator, and we get that according to equation number 1, x equals to 15 times root of 5 plus 10 over 2 times 2 times root of 5. Repeat again. According to equation number 1, we found out that x equals to 15 times root of 5 plus 10 over 2 times 2 is 4, so in total in the denominator we have 4 times root of 5. In the next step, we'll substitute 10 by square root of 5 times root of 5 times 2. And we get that x equals to square root of 5 times 15 plus 10. And 10 is square root of 5 times root of 5 times 2, all divided by square root of 5 times 4. So here we take out square root of 5 as a common factor from those two expressions in the numerator, and we get that x equals to square root of 5 is a common factor. So what is left from 15 times square root of 5 after we do from it square root of 5 is a common factor? What is left? It is actually 15 plus what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 is a common factor. What is left? It is actually square root of 5 times 2 all divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we get that x, that is the radius of this semicircle, that is the radius that we are looking for. X equals to either 15 plus 2 times square root of 5 over 4. On terms of numbers, x equals to 4.8680 units. Repeat again. X, that is the radius of this semicircle, equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this semicircle. In the drawing we have line segment PA that is tangent to the semicircle at point A. We also know that the length of line segment PA is 6. Line segment PQ equals to 4 units in its length. In addition, we know that line segment PS cuts the semicircle at points Q and S. And we also know that QS equals to QC. And this is angle PAB that is equal to 90 degrees in its size. And this angle SQC also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So first of all, I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 10. According to rule number 10 is true in any circle. So here we have point P is an example point in relation to this circle. So if from the common example point P, we will draw tangent PT to this circle, and from the same common example point P, we will draw line segment PB that cuts the circle at points A and B. Then the following equation will be true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing we have the common example points P, from the common start point P, we have tangent PA to this semicircle, and we also have from the same common start point P, we have line segment PS that cuts the semicircle at points Q and S. So all the requirements of all number 10 are met. Therefore, we can implement here all number 10. According to all number 10, PA square equals to PQ times PS. Again, PA square equals to PQ times PS. Repeat again, if we focus on the common start point P, according to all number 10, we get that PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ. PQ is 4, and PS, on the drawing itself, it is very easy to say that PS equals to PQ times QS. That is to say, PS equals to PQ, that is 4 plus QS. So in total, PS equals to 4 plus QS. Again, PS equals to PQ plus QS. That is to say, PS equals to 4 plus QS. So in total, according to rule number 10, we found out that 36 equals to 4 times 4 plus QS. Here we divided this equation by 4, and finally we found out that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted 4 from this equation, and finally we found out that QS equals to 9 minus 4, that is 5. So the length of this line segment or chord QS equals to 5. Chord QS equals to 5 units in its length. But because of the fact that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. Then I presented to you rule number 3 and then implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. In the drawing we have the straight line AB. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this is angle alpha and this angle beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. Actually, can implement rule number 3 in our drawing. Why? Because if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle, this is 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, this missing angle must be equal to 90 degrees. In order to complete the sum of the angles in the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. Then we join points P and C together by a straight line. By joining points P and C, we created the right triangle PQC. So I copied the right triangle PQC in the new page and we implemented the Pythagoras theorem in this right triangle PQC. This is the right triangle PQC that I copied from the original drawing. Side PQ equals to 4 units in its length. And we just right now found out that QC equals to 5 units. Here by PT is a abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So we found out that PC square, that is the square of the hypotenuse of this right triangle, is equals to 41. Then I copied the right triangle PAC in a new page and we implemented the Pythagoras theorem in this right triangle PAC. This is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given as the question. And we just right now found out that PC squared, that is the square of the hypotenuse, equals to 41. Here by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PAC, PC square equals to PA square plus AC square. PC square is 41, so we substitute PC square by 41. And it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. So in conclusion, we found out that 41 equals to 36 plus AC square. Here we subtracted 36 from this equation. And finally found out that AC square equals to 41 minus 36, that is 5. So AC square equals to 5. We took out of this equation and finally found out that AC equals to the square root of 5 units. This side AC equals to the square root of 5 units. So we can write down in the original drawing that AC equals to the square root of 5 units. We also know that this is a semicircle, and for that reason AB must be the diameter of the semicircle. So AB is the diameter, so if the radius of this semicircle is x, then the diameter AB must be equal to 2x. So AB equals to 2x, and AC equals to the square root of 5 units. So what is the length of line segment CB? CB from the drawing, it is very easy to see that CB equals to AB minus AC. Again, CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is square root of 5. So in total, CB equals to 2x minus square root of 5. You can write here that CB equals to 2x minus square root of 5. Then we completed the semicircle to a circle. And we extended side QC by a side line until it touches the circle. We defined the touching point of the extended side QC in the circle as M. And then I presented to you rule number 11 and we implemented rule number 11 in our drawing. Rule number 11 is about two chords that intersect with each other inside the circle. Whenever you have two chords that intersect with each other, you can implement rule number 11. In our drawing, we have a circle. Inside this circle, we have chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. Therefore, because we have here two chords that intersect with each other, we can implement the rule number 11. According to rule number 11, the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have also two chords that intersect with each other inside the circle. We have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Okay, again, in our original drawing, we have chord AB that intersects with chord QM at point C. So we have two chords that intersect with each other, therefore we can implement rule number 11. According to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Okay, again, according to rule number 11, AC times CB equals to QC times CM. AC equals to the square root of 5 units, CB is 2x minus square root of 5 units, QC is 5, and CM equals to B according to our definition. Here we divided this equation number 1 by square root of 5, and found out that 2x minus square root of 5 equals to 5b over square root of 5. Here we added to this equation number 1 square root of 5, and finally found out that according to equation number 1, two x equals to 5b over square root of 5 plus square root of 5. So here we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to overcome a factor with this expression. And we found out actually that 2x equals to 5b over square root of 5 plus, again, we multiplied square root of 5 by square root of 5, and then we divided by square root of 5, so we change nothing. For that reason, this operation is allowable. In conclusion, found out that 2x equals to 5b plus square root of 5 times square root of 5. Square root of 5 times square root of 5 is 5 over square root of 5. So in conclusion, found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we divided this equation number 1 by 2, and finally found out that x equals to 5b plus 5 over 2 times square root of 5. Okay. Then join points S and M together by a straight line. By joining points SM and M, we created peripheral angle SQM. This peripheral angle SQM equals to 90 degrees. And we have rule number 5 that relates to any peripheral angle that's equal to 90 degrees in its size. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So in the drawing we have a circle. Inside this circle we have peripheral angle MAN, and this peripheral angle MAN equals to 90 degrees in its size. In addition, we know that point O is the center of the circle. So this peripheral angle MAN that is equal to 90 degrees in its size rests on chord MN. And chord MN is the diameter of the circle. Why? Because it passes for point O, that is the center of the circle. And any chord that passes for the center of the circle must be the diameter of the circle. So if we're going to find out that peripheral angle MAN that is equal to 90 degrees in its size rests on the diameter of the circle. Why? Because MN is the diameter of the circle. Because it passes for point O, that is the center of the circle. In conclusion, peripheral angle MAN that is equal to 90 degrees rests on the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle SQM that is equal to 90 degrees in its size. Therefore, this peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on chord SM, and therefore, according to rule number 5, chord SM must be the diameter of the circle. Repeat again. Because of the fact that peripheral angle SQM equals to 90 degrees in size, therefore, according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on SM, therefore SM must be the diameter of the circle. We know that the radius of the circle is x, therefore the diameter SM must be equal to 2x. The diameter SM, that is also the hypotenuse of the right angle SQM, must be equal to 2x units in its length. Then I copied the right triangle SQM in a new page and implemented the Pythagoras theorem in this right triangle SQM. This is the right triangle SQM that I copied from the original drawing. Side SQ equals to 5 units in its length, and QM, in total QM equals to 5 plus B. Again, QM equals to 5 plus B, and QS equals to 5 units. the aperture SM equals to 2x according to rule number 5. So in this right triangle, triangle S2M, according to the Pythagoras theorem, SM square equals to QS square plus QM square. Again, SM square equals to QS square plus QM square. SM is 2x, therefore SM square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So we already found out that according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times root of 5. In the next step, we substitute x in this equation number 2 by the value of x that we found here in equation number 1. So according to equation number 2, we get the 2 times x squared. So it is 2 times x. X according to equation number 1 is 5b plus 5 over 2 times 4 to 5 all squared. So because it is 2x squared, that is equal to 25 plus 5 plus b squared. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, in this side of the equation, we are left only with 5b plus 5 square over square root of 5 square is 5. That is equals to 25 plus 5 plus b square. 5 plus b square equals to 5 square, that is 25, plus b square plus 2 times 5b, that is 10b. Then we open the brackets on this side of equation number 2 and found out that according to this equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. So, total, on this side of the equation, we have 25b squared plus 25 plus 50b over 5, and it is equals to 25 plus 25 is 50, plus b squared plus 10b. 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. So in total, in this side of the equation number 2, we have 5b squared plus 5 plus 10b, that is equals to 50 plus b squared plus 10b. Here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of the equation number 2, we left only with 5b squared plus 5. On the other side of the equation number 2, after cancel 10b, we left only with 50 plus b squared. Here we subtract b squared from this equation number 2, and finally found out that according to equation number 2, 5b squared minus b squared is 4b squared, so in this side of the equation number 2, we left only with 4b squared plus 5, that equals to 50. Here we subtract 5 from this equation number 2, and finally found out that according to equation number 2, 4b squared equals to 50 minus 5 is 45, so 4b squared equals to 45. We divided this equation number 2 by 4, and finally found out that b squared equals to 45 over 4. Here we substitute 45 by 9 times 5. So, according to equation number 2, b squared equals to 9 times 5 over 4. Here we took a root out of this equation number 2, and finally found out that b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3 over 4. The square root of 4 is 2. So inside the brackets, we left only with 5. In conclusion, we found out that b, according to equation number 2, equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute b. We can put the value of b that we found from equation number 2 inside b in this equation number 1. We did it, and we got that according to equation number 1, x equals to 5b, and b is 3 times square root of 5 over 2, plus 5 over 2 times square root of 5. So here we have 5 times 3, that is 15, so in total this expression equals to 15 times square root of 5 over 2, 15 times square root of 5 over 2, plus 5 over 2 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to account out of this expression. So x equals to square root of 5 times 15 over 2, plus 5 times 2 is 10, and then we divided by 2, so we change nothing. All divided by 2 times square root of 5. Here we moved 2 times square root of 5 to the denominator, and finally found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. 2 times 2 is 4, so in total in the denominator we have 4 times square root of 5. So in total, equation number 1, according to equation number 1, we found out that x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. Then we substitute 10 by square root of 5 times square root of 5 times 2. And found out that x equals to square root of 5 times 15 plus 10. 10 is square root of 5 times square root of 5 times 2 over square root of 5 times 4. Here we took square root of 5, we took out square root of 5 as a common factor from those two expressions in the numerator. And so x equals to square root of 5 is taken out as a common factor out of those two expressions. So what is left from square root of 5 times 15 after we do from it square root of 5 as a common factor? What is left? It is actually 15. Plus, what is left from square root of 5 times square root of 5 times 2 after we do from it square root of 5 as a common factor? What is left? It is actually square root of 5 times 2, all divided by square root of 5 over 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 get cancelled. And finally we found out that x equals to 15 times 2 times square root of 5 over 4 units. Again, x equals to 15 plus 2 times square root of 5 over 4 units. Or in terms of numbers, x, that is the radius of the semicircle, equals to 4.860. X equals to 4.8680 units. I repeat again, the radius of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, x equals to 4.8680 units. Okay, thank you very much.